Welcome to this lecture, guys. In this lecture, we'll be concentrating on bit manipulation. I think in the previous lecture, what we have done is we have already started a problem like finding duplicates in a string, and we have complete one method of it. Okay, so in this lecture, we'll be completely concentrating on problems on bit manipulation, actually, right? So if you see here in the previous lecture, what we have done is that we took a problem called find the duplicates in a string. And in this problem, we said that we are going to see three methods of it, and one method we have completed in the previous lecture itself. The nook and corner of the method has been already discussed, including the time complexity as well as the space complexity of the problem. So the method that for that particular method, the time complexity is actually order of n square, and the space complexity is order of 1. So now we'll start with the second method, which is called as using hash table or counting. So now we'll just start this method so that you will understand what is hash table, and it's a very important technique in the algorithmic world. In many real-time applications, this hash table methodology has been followed in many of the problems. Okay, so this is going to be one important technique which can help us in solving many problems. So just keep concentrated and just keep on watching the video. So we'll just start with the Excel sheet. First of all, I'll just take a string, for example, the same string that we have took in the previous lecture, finding. So FINDING followed by a null character. So this is the string that we have already taken in the previous lecture. Here also we'll take the same string, and we'll just take the corresponding index also. For example, 0 1 2 3 4 5 6 7, 0 to 7. Fine. So now we will be taking, see, first of all, what I need to tell you is that how many total characters are available. Totally 26 alphabetical characters are there. Am I right or no? Yes. Totally 26 alphabetical. Let me consider that only one case, lowercase characters only we are going to take for this problem. Okay. Later we will discuss about if uppercase is coming, what we can do, that we can discuss later. Okay. But now in this video, we will be seeing about if the complete string is a lowercase string without any space, then using hash table, how we are going to solve it. So how many alphabetical characters are there? Totally 26 alphabetical characters are there. 26 alphabetical characters. So what I'm going to do is that I'm going to store the count of each and every variable. For example, count of not variable, count of characters, alphabetical characters. So how much characters we have? We have A2 is a totally 26 characters. So we'll be storing the count of each and every character. So to store the count of each and every character, first of all, I need an array of size 26. Because for each and every element, I need to have a specific space to store the count. So what I will do is that I'll just start from here, and I'll be selecting totally 26 cells. Okay, so 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26. So all the marked cells are, I'm going to take it as a hash table. Whatever the elements, the cells that I have colored with yellow are going to be a big array of size 26, and let me take this array as hash of size 26. So we have taken an array hash of size 26. What will be the index? The index will start from 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25. Okay, 25. Do we miss anything? 0 1 2 3 4 5 6 7 8 9 and 10 is there in the same. position. Okay, so what I'll do is that I'll just add one more column, that's it. Okay, so entire column I'm going to add one more new column. So let me consider this to be 10 itself. Let us take this as 9 because shifting will take time, so I have added a new column. Correct, fine. Now what will I do is that I'll take the default value of the entire hash table to be 0. I'll tell you why I'm taking the value. See, this is index of the array. Whatever I'm writing here in the yellow cell is the value in a respective index. Okay, so in all the index I will be just taking the value 0 by default. I'm planning to start with 0. I'll just tell you the reason why we are starting with 0. Okay, fine. So now if you see, there are totally 26 characters, am I right? So I'll just write the 26 character one after the other. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So totally 26 alphabetical characters I have taken here. And you know very well that each and every character is having a corresponding ASCII code. So the ASCII code starts from 97, 98, 99, 100, 101, 102, 103, 104, and 105, and keeps on going. Okay, so it will take time if we keep on writing. So but it keeps on going up to 122. Keeps on going up to the last Z will be taking 122. Fine. Now what we are going to do with these things, see, what I will do is that I will store the count of the character A in the index called 0. I'll store the count of B in the index called 1. I'll store the count of C in the index called 2. I'll store the count of D in the index called 3. Okay, fine. This is what I'm going to do actually. Okay, so for that, doing that, how will I find? Do I need to check it? If it is equal to A, then store it in 0. If it is equal to B, then increment the value of 1th index. If I do like this, then I have to write 26 if else if condition ladder. So writing 26 if else ladder will be very, it will make our program very big actually. So in order to reduce the code complexity, the number of lines that we are coding, what we are going to do, we are going to generalize this. How we are going to generalize? I think A is having an ASCII value called 97. Why can't I convert this to 0? Converting 98 to 1, converting 99 to 2, converting 100 to 2, 3, 101 to 4, 102 to 5. How I can do? If you find both these things, if you find a common difference, when you subtract both this 97 and 0, you get 97. If you subtract 98 with 1, I get 97. If you subtract 99 and 2, I get 97. If I subtract 103, I get 97. If I subtract 101, 4, I get 97. So there is a very common difference between the ASCII code as well as the respective index of hash table. So what you can do, whenever you find a character, subtract 97 from that character, automatically you will reach up to the respective index where you need to store the count of the respective character. So what you do, initially assign everything to 0. For example, you find F. What is the ASCII code of F? ASCII code of F is 102. So what is 102 minus 97? It is 5. So 102 minus 95 is 97 is 5. So go to 5th index of hash table and increment the value. So already 0 is there. If you increment, it will become 1, which tells that F is occurring for one time. So far F is occurring for one time. Okay, then come to the next character. What is the next character? I. What is the ASCII code of the character I? It's 105. So what do you do? 105 subtracted with 97. What you get? You get index called 8. 105 minus 97 will give me 8. So what you do? Go to 8th index, increment the value, it becomes 1. Next, you have n. What is the ASCII value of n? Okay, so J is 106, K is 107, L is 108, and M is 109, and N is 110. So the ASCII code of N is 110. So when I subtract 97 from 110, what will happen? I will reach 13. So increment the value of 13, so it will become 1. Okay, what is next character? The next character is D equal to third index D. So what is the ASCII code of D? 100. 100 minus 97, 3. So go to third index, increment the respective value by 1. Then what is the next index, next character? I. So go to I. What is the ASCII code of I? 105. So 105 minus 97, you will reach 8th index and increment your 8th index value by 1. So already it is 1. So incrementing by 1 will make it 2. Next, what is the next character? N. So what is the ASCII code of N? It is 110. So 110 subtracted by 97, you find 13. Increment the value of 13th index, which is already 1. So incrementing it will make it 2. What is the next character? G. What is the ASCII code of G actually? 103. Subtracting 97 from 103 will give me 6. So in the 6th index, increment the value by 1. So it will become 1. So now if you look at this hash table, we have completed for all the characters. Now if you look at the hash table, whichever is having 0, which means that those characters are not occurring. If 3 is 1, then what is the corresponding character? D. So D is occurring for only one time. 5. F is occurring for one time. G is occurring for one time. I is occurring for 2 times. If some character is occurring for more than one time, then it is duplicate. So since the count of I is more than 1, then just take I as a duplicate value. So print I is a duplicate one. Then J 0. So J is not present in the given string. K is not present. L is not present. M is not present. Coming to N, N is present for 2 times, which tells that N is also a duplicate value. Okay, so this is what the method of method using hash table. So what we need to do, take a string, okay, find the length of the string. Why find the length of the string? Because no need of finding the length of the string here, because the reason is that you have to make only one traversal up to null character. So you need not to find separately, you need not to find the length of the string. Okay, fine. Now then what is the next thing? You have to take an integer array. Why integer array? Because we are storing the count, right? We are storing the count of the character. The count of the character will be always integers. So you have to take an integer array of size 26, where A is referred by 0th index, B is referred by 1th index, C is referred by 2nd index. Okay, fine. What you have to do, go each character, subtract each character by 97, you get a value. Go to that particular index, increment the corresponding value by 1. So this array which you are taking, integer array, the default value of all the index has to be 0. So start incrementing. Whenever you find a character, subtract it with 97, you get a resultant value. That resultant value, respective index you have to reach in this hash array, then that index you have to increment it by 1. So F corresponding ASCII code is 102. So 102 subtracted with 97, what you get? 102 subtracted with 97, I get 5. So the respective index called 5 is incremented by 1. It is holding the value called 1. So when you keep on doing, each and every character's count will be stored in some index. So if this index is having 2, means the corresponding character is I. How you find the corresponding character is I? Because you subtracted 97 from 105 to get 8. So now whichever index you are getting more than 1, count more than 1, take that index, add 97 to get back 105 again. So subtracting 97 will give you index. Adding 97 to the index will give you again the character's ASCII code. So when you have the ASCII code, then it's very easy to print the corresponding character. Okay, so this is what the plan that we will be following while we are implementing the problem. So shall we go and implement the problem? Yes. So I'll just create one more file for this hash table. So now what I will do is, I'll just save this by duplicate and using hash table.c. fine. So this is also duplicate finding function, but it is going to be of hash table. Okay, fine. So now what we will be doing is that we will be initially taking stdio.h library as usual, then followed by main function. Yes, that's it. So now what we are going to do, we will be declaring a character array of size 100, for example. Let me take. Now what's the next thing? Using scanf, what we do is that percentage yes comma str. Now what we are going to do is that we are going to write a function. We're going to write a function which is having void, and this function is like duplicate, and this function will find all the duplicate characters and it will print itself. So nothing we are going to return from the duplicate function, so I'm keeping the return type as void. So does duplicate function require anything? Yes, it require to for which string I need to find the duplicate. So you have one parameter, so which is a character array. So inside this, what you need to do, first of all, you have to take a hash table of size 26. You have to take a hash table of size 26. Okay, fine. I'll take an integer hash array of size 26, and by default all the values has to be assigned with 0. I've told you what will happen when we do this. Only one assignment, this 0 will be assigned to the 0th index. So when we do partial initialization, what will happen? All the remaining indices will be automatically filled with 0. This I have already shown you. Okay, fine. So I'm just initializing all the index values with 0. Fine. What is the next thing that we need to do? I need to iterate over the string. I need to iterate over the string, and I need to find the count of each and every character. So first of all, I need to iterate over the string. How? Using the null character. So initially I will take a variable called I, and I will just run a loop where the loop is going to tell that str of I, when it is not equal to null character, I can proceed. When it is not equal to null character, I can proceed, and I can start I can continue. So if it is if the respective character is not equal to null character, then we can continue our process. Suppose if we have reached null character, then we can stop the process. Okay, fine. So until we reach a null character, what we need to do? We need to take each and every ith character. We need to take each and every ith character, and we need to subtract 97 from it. I will get an integer value. Go to the respective index in the hash array and increment it by 1. So what I need to do, first of all, I need to take the ith character str of ith character, and I need to subtract 97. So when I subtract 97 from ith character, I get a number. You have to go to the respective index in hash. So what I will do is that I will write hash, and in the subscript column I will write this, because I need to go to the respective index. When I subtract with stri with 97, I get an integer value. That integer value respective index I have to go. So let me write it in the subscript part itself. So what will happen initially? First of all, the subtraction will happen and it will be replaced here, and the resultant index this hash will be accessing. Okay, what I need to do, I need to increment it. I need to increment the respective index value. So what str of I minus 97 will do? Str of I means f. What is f? F refers to 102 ASCII value. When you subtract 97, you get 5. So you have to go to hash of 5. Hash of 5. That is what I have done. So this is literally like hash of 5. Because if s has str of I is f minus 97 will be 5, so that 5 will be replaced here. After that only hash of 5 will be executed. So both are same. So writing it separately, storing in a different variable and giving it here, and giving the entire expression inside the subscript, both are same. We are entering the expression here directly in the subscript. So then after, what will happen? That fifth index element will be incremented. That some index, random index element will be incremented by 1. Counting, we are doing counting. That is why I said that this method is using hash table or counting. Also we can say it as like counting. Okay, after doing this, what I need to do? I need to go for the next character, and I have to find the occurrence of it. So I'm incrementing my I to move to next character. So at some point of time, this entire loop finish. So once this loop is finished, now what I need to do? I need to iterate over this hash table, and if some value was exceeding 1, then it is a duplicate value. So how to find the character? Respective index plus 97, I will get 105, the corresponding character. So what I need to do, I need to write one more loop which runs for 26 times, because I need to access the hash. What is the size of hash? Size of hash is 26. Okay, so let me start my I process again from 0, and I is, because I is already declared, so no need of declaring it again. Okay, so I is less than 26, then I plus plus. So what I need to do, first of all, if I need to check whether hash of I is hash, that is hash. So whether hash of I is greater than 1. So if it is greater than 1, I can simply say that definitely it will be a duplicate character. So what I will do is printf percentage %c is a duplicate character. It is a duplicate character. Is fine. So what is this percentage %c refers to? I told you that if hash of I is greater than 1, then I is the index. So if I is the index, then the element corresponding character will be I plus 97, because I have subtracted 97 to get the index. Now with the index, I'm adding 97 to get the character back again. We are doing the reverse process, that's it. From character, subtract 97 to get the index. Now I have the index, so if I want to get the character, then add 97. So subtract 27, we get index. Index plus 97, I get a character, vice versa. Okay, so here I can give I plus 97. So index plus 97, automatically character will be again, it will be found. Okay, so now let me save this entire file, and I'll be calling this function called duplicate, and let me pass str, the string called str, to only one parameter needed. Okay, fine. So we will now go for execution, and we will just check whether this is properly working or not, first of all. So okay, fine. So if you see here, I'm just going with, no, this is not the file, this is a previous file. So we'll go for this file. Okay, it's a duplicate of hash, duplicate of I think where we have saved this file is, yeah, inside this folder only. It is going to be hash table dot c. Yes, compilation is successful. We will just try to execute it. It's waiting for input to be given. So let me enter finding. So if you see here, I is a duplicate character and n. So I have not given a new line character, so it is printing in the same line. So now I'll just give new line character again. I'll just go with it. So if I give finding, if you see here, I is a duplicate character, n is a duplicate character. This is what in the previous video also we have seen. Am I right? So here also we will just give programming simply, and we will check what are all the duplicate characters, R and G and M. So G is a duplicate character, first of all. Then M is a duplicate character. Then R is a duplicate character. So these are the three duplicate characters that we have. And this method is also giving us the right answer. Okay, fine. So now we have finished implementing the concept, but now it is time for us to calculate the time complexity. It is time for us to calculate the time complexity. So how can we find the time complexity? Okay, so finding the time complexity, if you see, this will take 1 unit. Scanf will be taking 1 unit of time, and now comes a duplicate function. So we will find the time complexity of this function. So this is going to take 1 unit of time. For example, let me take, okay, 1 unit of time. I think we are initializing it, right? So how much time we are initializing it? Not only we are declaring, we are also initializing it. How much time? 26. Initialization could have happened in the automatically in the background. Automatically, we are not doing. We are only assigning only 1 0 to the 0th index. All the remaining elements are automatically changing to 0, so that we can take that totally 26 unit is coming here. Okay, declaring I will be taking 1 unit of time. Coming to this while loop, how much time this could have run? The previous video we have seen, this is literally like finding the length. So this process, if you see, this condition checking could have happened for n plus 1 unit, because n successful comparison plus 1 unsuccessful comparison we have done. The last failing condition also this could have checked. Then coming in, what, how many times body part will be executing? N times. So coming to this hash of things, if you see, expression subtraction is happening. So doing this subtraction 1 unit of time, and for doing this plus plus increment 1 unit of time, so totally 2 unit of time this will take. That too, this body part is executing for n times, so 2 into n, totally this will be executing for 2n unit of time, 2n unit of time. Coming to this incrementation, 1 unit, sorry, n unit of time, because body part will be executing for n times here. Here in this loop only I'm telling, okay, not for all the common loops I'm telling. For this loop, this is exactly body part will be running for n unit of time. Okay, coming here to this function. So coming to this for loop, you see initialization part, how much unit it will be taking? Only 1 unit it will be taking, because only one time only initialization will happen. Coming to condition, how much time condition will be done? 27 time, because you're running a loop for 26 time, which means that 26 successful comparison, and at last you will have one comparison failed condition to stop the process, right? That failed condition is also taken, so totally 27 unit of time. Then followed by, what is this I plus plus, how much time? That will also will be executed for 27 unit of time. You cannot take n here, because you know very well that you are running for 26 times. Here unknown times you are running, so I have taken n. Okay, fine. So now coming to this if condition, I have already told you that we have to go for the worst kind of case. So maximum what we can say is that this if condition is true in all the cases. So if it is true in all the cases, how much time body part will be executing for? One less than the condition. So condition is executed for 27, so this body part will be executing for 26 unit time. Coming to the printf statement, so let me think that this is also going to take 26 maximum iteration. Now what is the total time complexity taken by this entire function? 26 plus 1 plus n plus 1 plus 2n plus n. There is no nested loop here, so no need of any multiplication here, only we can go with addition. So 1 for the initialization here, then comes 27 for condition, 27 for incrementation, and 26 for hash, and 26 for the printing thing. So what is going to be the total time complexity here? How much n is here? N plus 2n, 3n plus n, 4n, so totally 4n. And how much numbers are there? All addition symbol. So 26 plus 1, 27, 28, 29. So totally this is going to be 56, 76 and 83. 83, 26 is 93, 103, 109. 109, 26 is 119, 129 and 135. So this is totally 135. You can add and you can check. Okay, so this is approximately equal to 4n plus 135. That's what the time complexity of this duplicate. So duplicate will be taking 4n plus 135 unit of time. So together, if you want to know the time complexity of the entire program, add all these three things. So what it is, 1 plus 1 plus 4n plus 135. So what you can do is that if you just find the overall sum, it will be equal to 4n plus 137. 4n plus 137. What is the highest degree of this polynomial equation? The highest degree is actually 1. So the highest degree is 1. Okay, fine. So highest degree is 1 means this part is what the highest degree part, n power 1. So what we can do? We can take only that part, ignoring all the constant terms, number terms. So this can be called as order of n power 1, which is generally called as order of n. So the time complexity over here is order of n. Coming to the space complexity, how much extra space we have taken? How much extra space we have taken? Here in the main function, we have not taken any extra array, extra space. This string is actually an input. We are using it to get the input, so we will not consider the space that we have occupied for getting input, but the extra space that we have taken here. 26 array of size 26. So what is this? Time is also 26. Space is also, because I told you for one block it is 26. One block in the sense of one integer block, okay, or for one character block. Generally we say that it takes 1 unit. So for 26 block it has to take 26 unit space. Coming to this variable called I, 1 unit. So totally how much unit we are taking? We are taking 27 unit space. So coming to space, so your time complexity, I'll just write it here. Our time complexity, already what we have concluded is our time complexity is equal to order of n. Now coming to the space complexity part, it is clearly seen that the space complexity is actually taking 26 unit of time. So when the equation is itself 26 only, no unknown variable is there, how we can rewrite this? We can rewrite this as 26 n power 0. So what is the highest degree? Highest degree is 0. So when the highest degree is 0, how we can rewrite this? Order of n power 0. So which can be rewritten as order of 1. Order of 1. Okay, but remember, we are having order of 26. 26 we are having it. 26 spaces we need to take, even though it is a constant space, but 26, even though you have to keep concentrating on the constant part also. Here the constant is very large, like 130, 137. See, 2, 3, 4, 5 is okay, but 137 is a very large constant. Okay, we will also keep this in mind. Okay, we will also keep this in mind. So what we will do is that generally, if you come to do the previous method, actually the equation that we get for the time complexity is this. So here in this place, what we will do is that for your first method, okay, for your first method, I'll just write the following equation also along with this. So for 1.1 method, the time complexity equation, because we also have to consider the constant cases. If both are order of n, then I have to consider the constant cases to verify which is going to be the efficient one. So here the equation for the time complexity is this, and the equation for space complexity for the same method, if you see, space complexity of the same method, that is a previous method that we have seen. If you see here, the space complexity, this is 5. Just simply 5 into n power 0. So what you can write is that simply 5 is the space complexity. So coming to 1.2 method, which is the current method, if you see the time complexity of the current method, what is the equation that we have got? The equation that we have got is 4n plus 137. We will keep a note on it, okay, which will help us in the further concept. The next concept that we'll be seeing is using bit manipulation, right? So there it will be helping us. Okay, there it will be helping us. So if you come to the space complexity of this problem, if you see the space complexity of this problem, and this problem will take totally how much space this will take? 26. So equation is itself 26. So comparing this solution, comparing the first solution, the second solution is efficient in terms of time complexity. You can able to see. See, order of n is always less than n square, right? N is 5, n square is 25. So n is always less than n square. So if you see time complexity, our new method wins it. But coming to the space complexity, if you see, I think our new method is losing it by occupying not very extra space, but what we are telling is that we are using a little bit extra space, and by using that extra little space, what we are doing? We are decreasing the time complexity. So by using little bit extra space, we are decreasing the time complexity. Okay, so always I will tell you that time complexity and space complexity have to be balanced. I think here in the second method it is balanced. So in the third method, using bit manipulation, I will tell you how to decrease both your time and space complexity. For this problem alone, I'm telling. I'm not speaking about the general case. For only this method only, I'm just telling it. Okay, fine. So in this session, we'll be finishing off with this content. In the next lecture, we'll be starting with this using bit manipulation, how to solve the same problem. Okay, so we have seen the time complexity and space complexity of the first method, time complexity and space complexity of the second method also, and we have also implemented the second method also, and we have implemented also the first method also. The left shift operation, then about the bitwise ORing, which is also called as merging, bitwise ANDing, which is also called as masking. So we also took a problem like find the duplicates in a string, and we have taken three methods, and I think so we have seen already two methods completely, and also including the time complexity as well as the space complexity of the problem. So today we will be seeing the same problem but using a different technique called as bit manipulation. So actually our motive is to see about the bit manipulation, but in order to show you the importance of it, the efficiency level of it, I have taught you also two other methods also. So now we will just start with the other methods, the one more method which is using bit manipulation. Okay, we can just start. Okay, so I have taken a Excel sheet here. So what I will do is generally I'll take a string, initially the same string that we have taken for the other method also, finding, and followed by a null character, finding followed by a null character. So if you just start taking the index of all these characters, so it starts from 0 1 2 3 4 5 6 7 7. So totally how much index we have? We have starting from 0, we have up to 7th index. Totally 8 characters. It's totally 7 characters only we have. 7th index is filled by null character. We are not taking it in the length. Okay. So up to 6 only it is a string. So totally 7 characters, and the index starts from 0 ends at 6. Fine. So now what we want to find? We want to find the duplicate characters using bit manipulation. I'll just show you how we are going to do it. Okay, so we already know that totally how many alphabets we are concentrating on. 26 alphabet from lowercase a to lowercase z. Totally 26 alphabetical characters are there. So what I'm going to take is that 26 bit. I'm going to take 26 bit because this is bit manipulation, right? So we're going to take 26 bit, but already I have told you somewhere that the smallest unit of the smallest memory block of computer is actually 1 byte. In the basics I have told you 1 byte. The very smallest block is itself 1 byte. How much 1 byte is? 1 byte is equal to 8 bit. So you can have a multiple of 8 as a bit. You cannot have partial. So either you can take 32 or you can go with 24, but exactly you cannot take 26 bit. So what I will do is that we cannot take 2 bit short, but we can take extra bit. Okay, so we will take 32 bit. We will take 32 bit. How to take 32 bit? How to take 32 bit? I'll tell you. If you take integer, apart from turbo C, it is in the modern compilers, it is taking 4 byte. Integer is taking 4 byte actually. Integer is taking 4 byte. How much 4 byte is? If 1 byte is equal to 8 bit, then 4 byte is equal to 4 into 8, which is equal to 32 bit. Which is equal to 32 bit. So what I can do is that we can take a single integer variable. That single integer variable will be having 32 bit inside the memory block. Hope you understand. See, we have taken a string, and we already know that there is a possibility of either 26 character. Among 26 characters, some character will be occurring in the string. So we are going to do this using bit manipulation. So I want to take certain bit. So 26 bit I want, but we cannot take 26 bit because the smallest block is itself 1 byte, which is equal to 8 bit. So you can take a multiple of 8 only. So we are taking 32 bit. How we are taking 32 bit? We know very well that an integer variable will be taking 4 byte of memory, whereas 4 byte of memory is equal to 32 bit. Okay, fine. Let me declare a integer variable. For example, I'm declaring an integer variable called x. So once I declare an integer variable called x, what will happen? 32 bit will be allocated. 32 bit will be allocated. For example, I'll just show you. Starting from here, we'll just count once. 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32. So totally 32 bits we have taken so far. Okay, total 32 bits we have taken so far. Okay, so if you see, totally 32 bits have been taken, and already I have told you that array index will start from the first block, but for a binary representation means for every bit the index will start from the right hand side. Usually for array starts from left hand side. For binary representation or for the memory blocks, for the bit representations, the index starts from the right hand side. So here it is taken as 0th bit, this is taken as 1th bit, lowest significant. We start from the lowest significant part, which is the rightmost bit, lowest significant bit. Okay, this is 2nd bit, 3rd, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31 and 32. So totally, for example, 32 bits we have taken. 32 bits we have taken so far. Okay, I think up to 31 it is enough. Up to 31 it is enough because we are starting from 0, right? So 0 to 31, 0 to 31 it is totally 32 bit. Okay, so totally 32 bit we have taken. Okay, so what we are going to do, each and every bit I want it to be by default, we are going to take it as 0. I'll tell you why. This is similar to hash table only, but we are taking it as an integer variable, a single integer variable. Instead of taking an array of 26 arrays, see, instead of taking an array of size 26, we are taking a single integer variable which is having 32 bit inside, and we are going to use the bit now. Okay, so we will just go with implementing 0 for all the blocks one after the other. So all the bits have been initialized with 0. Okay, all the bits have been initialized with the 0. Okay, fine. So now what I need to do, all the bits have been initialized with 0. So now what we will be doing is, I'll just first of all go to the given string. We'll just take the ASCII value of each and every one. Okay, what is the ASCII value of F? We know that A starts from 97, A 97, B is 98. See, if you see the ASCII code of F, it is 102. ASCII code of F is 102. What's the ASCII code of I? ASCII code of I is 105. You can verify. Okay, the ASCII code of N is 110. The ASCII code of D is 100. ASCII code of I is again 105. ASCII code of N is again 110. ASCII code of G is, it is 103. Okay, so we have taken the ASCII code of everything. So what in the previous hash table also I have told you that 0th index will be referred by A, character A. 0th index I'm going to represent it using A. 1th index I'm going to represent it using B. 2nd index we are going to represent it using C. How we are going to do this? We told that the ASCII code of A is 97, ASCII code of B is 97, ASCII code of C is 97, sorry, ASCII code of B is 98, ASCII code of C is 99. Okay, so now how to convert 97 to 0, 98 to 91, 99 to 2? We already saw that we need to make a we need to subtract 97. We need to subtract 97 from the ASCII code, so automatically we will be reaching either 0, 1 or 2. Similarly, here also in the bit manipulation also, what we are doing is that the character A is going to be represented by using the very low significant bit, 0th bit. B will be represented here. So I'll write the characters, corresponding characters here on the above face. So A, B, C, D, E, F, G, H goes on. Okay, so E, F, G, H, and it goes on. So 0th bit is represented by A, 1th bit is represented by B, 2nd bit is represented by C, 3rd bit is represented by D, 4th bit is represented by E, 5th bit is represented. So this goes on. So now what we are going to do is that we are going to count it. How to count it? Okay, how to count? We'll just tell you. First of all, taking F. So F ASCII code is 102. If we subtract 97 from 102, what we will be getting? 102 subtracted by 97 will be getting 5. The difference will be 5. So it means that 5th bit is going to represent our F. 5th bit is going to represent F. Yeah, here you can see 5th bit is represented by F. So now what I need to do is that respective 5th bit is having 0. See, if all the entries are 0, which it means that if all the bit is 0, it means that X is equal to 0. X is equal to 0. Because in the basics itself, I have told you, if X is equal to 0, then the representation is all zeros. All the bit will be zeros. That is what the corresponding binary representation of 0, decimal 0. Okay, so this is actually when we initialize 0 to an integer variable, automatically the 32 bits will be automatically allocated with zeros. Okay, we have taken a variable X which is assigned to 0. That is why all the bits are taken as 0. Okay, fine. Now what I have to do? I have to change this 5th bit to 1. I need to change this 5th bit to 1. How to change this 5th bit to 1? Because I have to count. F is occurring for 1 time, so I need to increment the count of 5th bit, which is going to tell me that F is occurring for 1 time. How to do it? So if already the bit is 0, how to convert it into 1? I think we have an operation called R. So when we take a bit and when we do OR operation with 1, definitely 0 can be converted to 1. Am I right or wrong? Because 0 or 1 or 1 or 1. Okay, see, if you take the table or the OR gate table, 0 0 will give you 0. Apart from that, 0 1 also will give you 1. 1 0 also will give you 1. 1 1 also will give you 1. So if at least one bit is 1 bit is true, then the answer also will be true. So here I am just doing OR operation with 1, so at least 1 bit is true here, so resultant answer will be 1. So if I want to change a bit from 0 to 1, then I need to do a OR operation with 1. But you need to do the OR operation with exactly this bit alone. With the 5th bit alone. You should not do OR operation with all the other bit. You have to do the OR operation with only 5th bit. How to do only OR operation with 5th bit? How to do OR operation with only 5th bit? So you want a bit 1 to be representing 5th bit. So what we can take is that I'll be taking another variable y is equal to 1. I'll be taking one more variable y is equal to 1. So what is a binary representation of 1? So here I'll just write what is a binary representation of 1. The lowest significant bit will be 1. All the other bit will be 0. The lowest significant bit will be 1 and all the other remaining part will be zeros. It goes on. All the remaining part are zeros. And now what I'm telling is that we have an operation called left shift operation. Using this left shift operation, what we will be able to do is we will be able to move this 1 to any number of steps. So if you want exactly in the 5th bit, if you exactly want 1, what you can do, if you do 1 left shift, it will come here. Your 1 will come here. If you do left shift by 2, then your bit will move here. If you do left shift by 3, it will move here. Left shift by 4, move here. Left shift by 5, you move it. So if you exactly want the 5th bit to be 1, then you can take 1 and you can left shift it for exactly k times, which means that if you want kth bit to be 1, then you can left shift it for k times. So 1 left shift 5. 1 left shift 5 will give you the corresponding binary representation like this. Your 0 here, 0 will be there. Okay, 1 left shift 5 will give a representation like this, because left shift operator will be moving the bit called 1 towards the left side. It will be moving the bit to the one, it will be moving the bits towards the left side. So I'm moving the bits by 5 steps. So the bit which is here in the 0th bit will be moved to the 5th bit when I do left shift by 5. So after doing left shift by 5, now only one bit is there. That one bit is exactly representing 5th bit. Now if you do OR operation, what will happen? Now if you do OR operation, then exactly this bit will be converted to 1. OR operation. See, you have to do OR operation between these two entire representation. When you do entire representation, what will happen? 0 or 0, 0, 0 or 0, 0, 0 or 0, 0. But in this one column, it is 0 or 1, which will convert it to 1. So the resultant answer again have to be again stored back in the same variable called x. You'll be getting a resultant answer. That resultant answer have to be again stored back in the same variable called x. Okay, so what we are going to do is step 1. We are going to take a variable called x, and we will be taking a variable called x, and we will be initializing it to 0. Then, so I go to the string, I take the respective ith index character. I'll be taking the respective ith index character, and I'll be converting that ith index character. I will be subtracting the ith index character by 97, and after subtracting that corresponding ASCII code by 97, I get a resultant answer. That many times, whatever the resultant answer I get, that many times, what I will do is I will take one more variable called y. I'll take one more variable called y, and I'll be left shifting it by that many number of times. Which number of times? Exactly the difference you get, right? Difference. Let me take this difference as k. Let me take the difference as k. 102 minus 97 is taken as k. So what you can do, you can say that you take a variable called y assigned with 1, and you do left shift operation for exactly k times. So you get one more answer. So what you do is, original variable is x and the new variable that you got is y. Do OR operation between both these things. Do OR operation. So when you do OR operation, what will happen? Exactly the kth bit will be converted to 1. Exactly the kth bit will be converted to 1. So whenever you do OR operation, what it means, it is called as merging. So we are doing a merging process. When we do a merging process, if we want to switch some bit on, if a bit is 0, it means that the bit is in off state. If the bit is 1, then it is in on state. So if you want to switch some bit to on state, then you have to do merging process after doing left shift operation, because whichever bit you want to switch it on, you have to first of all move to that bit exactly. You have to move this one to exactly the same bit. So how to move that? Using the left shift operator. Okay, so initially you take x equal to 0, then you go to the string respective ith index, and respective ith index, what you have ASCII code. That ASCII code you subtract it with 97, you get a resultant k. That means you take a new variable called y and do left shift it by k number of times, and the x has to be ORed with y, and the resultant answer has to be again stored back in the x itself. One thing. But suppose, so what will happen after doing OR operation? This bit will become 1. This bit will become 1. Okay, fine. Again I will take 1. Again I will take y equal to 1. I'll move to the next character, which is called as I. What is the corresponding representation of I? 105 minus 97, it is going to be 8. So k equal to 8. So if k is equal to 8, what you need to do? You have to do left shifted this for 8 times. So when you do left shifted for 8 times, what will happen? This 1 will be moved exactly to the 8th bit, because 8 times you have to left shift. 8 times if you left shift, exactly it will reach the 8th bit. So this will become 0. Now exactly what have to happen? This has to be ORed to make this bit 1. So what will happen? When you OR it, this bit will become 1. So you switch it on. Okay, switch it on. Okay, 2 processes over. For 2 characters, the process is over. What is the next index? Next index is 2, which is having n. The corresponding ASCII code is 110. So what is 110 minus 97? It is like 13. K is equal to 13. Okay, fine. So when k is equal to 13, if you just come here, I will take again, I'll just take again 0, I'll take again 1, y is equal to 1, and I will left shift this for 13 times because k is equal to 13. So if I do left shift for 13 times, what will happen? I will reach exactly this 13th bit. So what will happen is 0 0 0 0, fine. So exactly I'll be reaching this 13th bit, and this 13th bit is actually represented by I. So not I think it is n, it is represented by n. So what will happen now? You have to make a or operation. When you make or operation, automatically this bit will be converted to 1. That's it. Again, take it as 1, and now you go to next character, which is D. If you subtract 97 from this character, you will be getting 3. K is equal to 3. So what you need to do? You need to do left shift by 3 times. So 1 left shift 3 will give you exactly the third bit will become, the third bit will again exactly it will become 1, because you're doing left shift bar 3 times, so automatically your 1 will reach here. So this bit has to be converted to 1. If you do OR operation, exactly this bit will be converted to 1. Fine. Again, take 1 and go to next character. What is the next character? Next character is I. What you will happen, what is the corresponding ASCII code? 105. So if you subtract 97 from 105, what answer you will be getting? K is equal to 8. So again, you have to do left shift by 8. So when you do left shift by 8, what will happen? Exactly this 1 will reach exactly 8th bit. 8th bit. And now if you see, now comes a one more point added. Okay, I will add one more point. What it is? So far what happened is that the 8th bit, already whatever bit we wanted, that bit was already 0. We were merging it and we were converting it to 1, but here it is already 1. If it is already 1, what it means? Already it was occurring, the same character was occurring for one more time. Already it has occurred somewhere. So when already the bit is 1, when already the bit is 1, then what you can say, this corresponding character is a duplicate character. When already the bit is 1, you can say the corresponding character is a duplicate. How will you find that the existing bit is itself 1? You can do AND operation, because when you do AND operation, if the resultant value is 1, it means the original bit is also 1. But when you do AND operation, if the original bit is 0, you will be getting answer 0. So do AND operation. If the resultant answer is 1, it means that the original bit is 1. If the resultant answer is 0, then the original bit is also 0. Okay, so you know very well that AND operation means both these things have to be 1. Both these things have to be 1. So when both these things are 1, then it means that already the character has occurred somewhere. So what you're doing here? AND operation. What is AND operation? Masking. This is called as masking. What is masking? Checking whether a bit is on or not, on or off, is called as masking. Okay, checking whether a bit is on or off is called as masking. If the bit is an off state, converting it into a on state or making it off. So either making the bit on or off is called as merging. Checking whether it is on or off is called as masking. So checking process is masking. Converting it into either 0 or 1 is called merging. Okay, there is a bulb. Masking means checking whether the bulb is on or off is called as masking. But merging means switch. If the light is an off state, on it. If the light is in on state, switch it off. So doing the process is merging, checking the process is masking. Okay, I think we are using the left shift operation, we are using merging, we are using masking. I think all these 3 things I have already taught you. Using those 3 things only we are proceeding. So what we need to do, first of all, we need to take a variable called x, which is initialized to 0. Then we have to take a variable called y and we have to initialize it to 1. Then we have to go to the ith index character of the original string and we have to subtract it with 97 to get the answer k. And after getting the answer k, what you need to do, you have to left shift your y variable. You have to left shift your y variable by k times. You have to left shift your variable by k times. So after doing this k time left shift, what you need to do, you have to r your x and y, and resultant answer has to be again stored back in x itself. If That's a condition. What is the condition? If the existing bit is 0, then you can do this merging process. But if your existing bit is 1, if your existing bit is 0, go for merging process, or but if your existing bit is 1, what you need to do? You should not do this merging process. If the existing bit is 1, just tell that this is a duplicate character. Okay, so now what we will be doing is, first of all, we will be doing masking. What is masking for? Checking whether the bit is 1 or 0. So I will do masking to verify whether the taken bit is 0 or 1. If through masking, if I find that the given bit is 1, then I don't do any merging process. Simply I will tell that this is a duplicate character. Suppose if masking is telling me that the original bit is 0, then I will do the merging process to change this bit into 1. So this is what we are going to keep on doing. Okay, so I'll just take a file and we'll start implementing so that you may get a exact idea of what we're going to do. So duplicates of bit manipulation, so bit.c. So I'll just take as include stdio.h followed by main int main, and followed by inside this main block. If you see, what we have to do is, first of all, we will be taking a character array, for example, of size 100, and using scanf I'll be receiving this percentage yes comma str. Okay, fine. Now what is the next thing? I have to write one more function. For example, I'll write void duplicate function because I'm not going to return anything, so I'm writing a void duplicate function. So now what is the information that is required for doing the task? Actually only the string. You need not to find any length here. Okay, so the parameter is going to be a character array called string str, character array called str. Okay, fine. So now inside this duplicate function, what we need to do is actually we will be first of all taking a integer variable called x, and we will be initializing it to 0, because when we initialize to 0 only, all the 32-bit will be taken as 0. Okay, because x is an integer variable which is allocated with 4 byte of memory, and 4 byte means it is equal to actually 32-bit, and when you convert 0 to a 32-bit binary representation, then all the 32-bit will be 0 bit only. Okay, the corresponding binary representation of 0 is all the 32 bits 0. Okay, fine. Now what is the next thing that we need to do? We need to take one more variable called y. We need to take one more variable called y, and we need to initialize it to 1. We have already seen that also in the process. Now what we need to do? We need to start visiting the we should start visiting each and every string. So I will just write a for loop for doing it. So for the for loop, I want one more variable called I. So I'll start my checking process from 0th index, and I'll go up to null character. So str of I, if it is not equal to str of I, if it is not equal to null character, then I will be checking that character. So up to null character we are going to move using this for loop. Okay, fine. So inside this for loop, what we are going to do? First of all, we will be taking ith index character and we'll be subtracting it with 97. I have already informed you. And the resultant answer, I told you that I will be storing it in a variable called k. Okay, I have taken a variable called k. So k is equal to str of I subtracted by 97. Okay, fine. Now what you need to do, you have to left shift your y by k number of times. So y is equal to y means it is 1. Okay, it is 1. So y is equal to y left shift k. Okay, fine. Y left shift k. So now with the resultant y, what you need to do, you have to check whether the respective kth bit of x is actually already 1 or 0. A respective kth bit of x is already 1 or 0, because if the kth bit of x is already 1, which means that it is already a duplicate character. Which is duplicate character? I is a ith index character is a duplicate character. But if the kth bit is 0, then this is the first occurrence of the ith index character, we can say. Okay, so after finding the value of y, what I need to do is we need to make a checking process. How to check it? If we need to do masking process to check whether a respective bit is on or off. So if x and k, if x and k is equal to 1, then we can say, I've already shown you, when you do AND operation, when the resultant answer is 1, which means that the original bit is a non-state. The kth bit of x variable is a non-state. Suppose if the resultant answer is 0, then the kth bit of the original string is 0. So what you can say here, if it is equal to 1, it is already a visited place, it is already a visited character, so it is called as a duplicate character. So what you can do here is printf %c is a duplicate character, followed by a new line character. Okay, so comma, what is the next thing? Next thing is we say that ith index character is a duplicate character. Fine. Suppose if it is 0, else part, if x and k, if doing the masking process is giving you 0, which means that the original bit is 0. If the original bit is 0, what you need to do, you have to convert it to 1 in order to tell that it is occurring for one time. So what you need to, how will you change a particular bit to 1? By doing merging process. How to do merging process? OR operation. So if I want to on, then I have to do OR operation with 1. If I have to convert it to if I have to convert it to on, then I have to do OR operation with 1. Okay, so what I will do is that x is equal to x or y. Okay, I have done the merging process also. Why this merging process? See, what is this happening? This is called as actually masking, which is called as masking, and which can be also called as checking whether the kth bit, okay, whether the kth bit is 1 or 0. That is what the work of masking. What's the work of merging? Work of merging is switching kth bit on. Okay, so switching kth bit to 0 is what the work of merging. Kth bit to, sorry, not 0 to 1. Okay, fine. Okay, I think this will work actually. Okay, so we'll just call the function called duplicate. We'll just call the function called duplicate, and we will pass the string str, and then we will just go for the execution part. So we are in the compilation is successful, so we'll go for execution. So I'll just enter the same finding. So this is not printing anything. We'll just check whether so if you observe, there are a few mistakes that I have done here in the code. So one important thing is that every time you have to take your y back to 1. Am I right? Every time we are starting from y equal to 1. But here what we are doing is what we are doing is that we are not starting it from 1 every time. So we are continuing the value of y, which is one big mistake. So your y has to be starting with 1 every time when you start. So at the very first line of the loop, I'm just initiating y to 1, which is one important mistake that we have done. So apart from that, I think everything is okay. Yeah, one more important mistake that we have done is that when you do AND operation with x and y, so see if you see here, I'll just show you one thing. 1 0 0 0. Okay, or otherwise we can say that the last bit, this is also 1. Okay, so 1 0 1 1 is one representation, which is called as x. Okay, so this is 11, the representation of 11. So x is equal to 11 means this binary representation. Okay, I'll take one more variable called y, and y is equal to 8. 8 means it is equal to 1 0 0 0. 1000. Now when you do AND operation between these two bits, what will happen? The resultant answer will be 0 and 1 will be 0, 0 and 1 will be 0, 0 and 0 will be 0, 1 and 1 will be equal to 1. So what you get is that when you do x and y, the resultant answer is not 1, because our representation of x is 11, the representation of y is 8. It means that the resultant answer is also equal to 8, which means that if both these bits are 1, if both these bits are 1, the resultant answer will be also equal to y. Suppose if this is equal to 0, then the answer will be 0. Then the answer will be entirely 0. So what we should have done is that x and y is not equal to 1, it is equal to actually y. So if x and y is equal to y, then we can say that the original kth bit is 1, already switched on. Then we can say the respective character is a duplicate character. I think these are the two mistakes that we have done here in the code. So now what we will do is this, we will go with the implementation, compilation here. So compilation followed by execution. So it is waiting for the input to be given. So when we give finding, then it is rightly giving us that I is a duplicate character and n is a duplicate character. So we will just give one more word called as programming, and we will just check. Yeah, here also you are able to see that R is a duplicate character, M is a duplicate character, G is a duplicate character. Okay, so we are done with this bit manipulation methodology of how to solve finding the duplicates of a string. Now we will go with binary, we will go with the time complexity. We'll go with calculating the time complexity of this code. Okay, so if you see, taking str of 100, let us consider that this is going to take 1 unit of time. This scanf will take 1 unit of time. This duplicate function, then you have to find the entire time complexity here. Okay, so if you see here, this line, okay, so I'll just take these command lines. Actually, I'll just take, because it will be a little confusing for us. Okay, so now if you see here, how many variables we have taken? 1 2 3 4. So let me consider that 4 unit of time. Then coming to this loop, this is a loop which runs for exactly n time. What is n? N is a length of the string, is generally I'm taking it as n. So 0 to n literally we are running. Okay, if you just notice, so you can say similar to yesterday session, if you see, initialization will be exactly taken for 1 unit of time. Initialization exactly one time only it will be executing, so 1 unit. Then coming to condition part, condition will be executing for n plus 1 unit, because n successful condition checking and 1 unsuccessful, the failure condition checking is also included in the time process. Then similarly coming to the process of increment, then it is taken as also, whenever I told you already, condition and increment will be taking the same unit of time, so it is also taking n plus 1. Now coming to the body part, if the condition is n plus 1, then definitely body part will be executing for n time. So this I is equal to 1 has to be executed for n unit. Then this line subtraction you are doing, so this will be also taking n unit of time, because n time the body part will be executed. So this also will be taking n unit of time. Let me consider that this condition is also going to take n unit of time, because we have to go with the worst case, right? So if condition is n unit, then the body part of if condition is also n unit. Okay, it is also going to be n unit. Okay, so either if or else. Okay, so either this n plus n or either this n plus n. So however we are just generalizing it. Okay, so both things will not happen at the same time. So either take n unit for this, n unit for printf, or n unit for else if, or else, or n unit for this statement. Okay, so we have taken already for if condition, so no need to take for else condition. Okay, fine. Even you can also take, the time complexity will not change. Okay, fine. So now let us just add everything together. If we add everything together, then it is 4 plus 4 added with 1 unit for initialization, n plus 1 unit for condition, then n plus 1 unit for incrementation, n unit for y is equal to 1, n unit for k, n unit for left shift operation, then n unit for if condition, n unit for printf. So how much this is going to totally be equal to? 1 2 3 4 5 6 7 n plus 7n plus the constant is going to be 4, 5, 6, 7. So 7n plus 7. So 7n plus 7 means the highest degree is this one, 1, n power 1. So if highest degree is n power 1, 1 is the highest degree, so we can generally write it as order of only that part only we will be taking. Okay, so this can be called as n power 1, order of n power 1. So n, normally n power 1 means it is n, so order of n is the time complexity of this duplicate. So instead of taking that, first of all I'll just send this 7n plus 7 here to the main function. So this will be taking 7n plus it is 7. Okay, 7 unit of time. So now the total time complexity of the entire program is equal to 1 plus 1 plus 7n plus 7. So totally this is equal to 7n plus 9. Again the same thing, the highest degree is 1, so you can say that this is order of n, order of n. Okay, fine. How about the space complexity? How much extra space that we have taken so far? The extra space that we have taken is that these variables only. See, this is str is a input space, so we will not include the space we have taken for reading the input. So extra spaces, what is extra spaces? These variables, x 1 unit of space, y 1 unit of space, i 1 unit, k 1 unit. So totally 4 unit of space only. So coming to space complexity, space complexity is totally 4 units. So complexity is equal to just 4, where it is 4 means it can be also rewritten as 4n power 0, whereas highest degree is 0, so you can rewrite this as order of I think the highest degree is 0, right? So we can take only that part alone. So n power 0 we are going to take, n power 0. What is n power 0? N power 0 is equal to 1. Always anything power 0 will be equal to 1. So space complexity is order of 1 and time complexity is order of n for this duplicate. So we can just go back to this and we will also just come to a conclusion about the time complexity as well as the space complexity. Here this is time complexity, not space. So here, what is the time complexity of bit manipulation? Time complexity of bit manipulation is the order of n, and the space complexity of this problem is actually order of 1, which we have already proved. Okay, so now what we need to do is that we need to compare all these 3 methods to find which is the efficient method. Okay, so I'll just write it here. I'll just take this Excel sheet. Actually, I'll just take this Excel sheet, just remove all these things, all these stuffs. Okay, so now what we will do is that I'll just take method 1 followed by method 2. Okay, method 2 and followed by method 3, and this is going to be time complexity, and this is going to be, for example, space complexity. Okay, so now for the method 1, what is the time complexity? For the method 1, the time complexity is order of n square. So this is order of n square. So what is the time complexity of method 2? Time complexity of method 2 is order of n. Time complexity of method 3 is also order of n. So method 2 order of n, method 3 is also order of n. Now coming to the space complexity, the space complexity of the first one is order of 1, and the space complexity of the second one is also order of 1. The third one is also order of 1. So order of 1. So order of 1 and order of 1. All the 3 things are space complexity order of 1. So now we are going to just compare and we are going to find which method is going to be efficient. So first of all, we will just have a we will just decide which method 1 or method 2 is going to win. Okay, we are going to have a competition between method 1 and method 2. We will just check which is going to have the efficiency. Okay, so comparing your space complexity, actually both are same. both are same, tied. Okay, the match is tie. Now coming to the time complexity, n square and n. See, if you take n is equal to 5, n is equal to 5, order of n means it is 5. Order of n square means n square, 5 square is 25. So n square means 25, n means 5. So which is lesser actually? Generally, normal mathematical terms, either n is lesser or n square is lesser. And n is lesser. So coming to the time complexity, your method 1 wins. Am I right or wrong? Okay. So method 2 wins in terms of time complexity. So red color, it is losing. Coming to space complexity, both winning because both is equal to same. So overall, if you see, method 2 is winning very clearly comparing your method 1. So comparing your method 1, your method 2 is winning. So now, since your method 2 is efficient than method 1, so you need not to compare method 1 and method 3. You can directly compare method 2 and method 3. Okay, we will just compare these two things. When you compare these two things, if you see, method 2 and method 3 are in tie because both are order of n. Coming to the space complexity, order of 1 and order of 1, both are same. So both time complexity, space complexity are equal here between method 2 and method 3. So how to find the efficient method? Do you think both the methods are same efficient? No. Two methods cannot be with the same efficiency level. So when the general order of n or order of growth time complexity, general time complexity, then what we have written is equal, then what you do is we have also having the equation, right? We're also having the equation. So take this equation. Okay, so take this equation, 4n plus 137, 4n plus 137, and also for the new thing you have got 7n plus 9. 7n plus 9. Okay, so we will be taking this into account. So for the method 3, the equation is 7n plus 9. So coming here to your hash table method, second table, if you see, the method is taking 4n plus 137. So that also we will just take 4n plus 137. So coming to your space complexity. So coming to your space complexity, if you see, method 2 is taking exactly 26 unit of time, 26 n power 0. Already we have taken 26 n power 0. So coming here to the method 3, if you see, method 3, if you see, it is just 4n power 0, 4n power 0. 4n power 0. Fine. Okay, so now we will just have a competition. Okay, so now what you do is that one task that I can give you is draw a graph for the polynomial equation 4n plus 137 and draw a graph for the polynomial equation 7n plus 9. Okay, draw a graph by taking x and y axis. Draw a graph for first polynomial equation and also for the second polynomial equation for their growth. Okay, for their growth. Okay, then clearly you can say that your space complexity method 3 is winning clearly. So here method 3 is winning clearly, or method 2 is losing in terms of space complexity. So coming to your method 3, the constant term is very large. So here multiplication 4n 7n, if you see, the method 3 is having little bit greater, but coming to the constant, if you see, 9 is very lesser and 137 is very high. So what you can see is that a minute difference can be there between method 2 and method 3, which you can notice when you're writing a growth graph. When you write a graph, at some point of time method 2 and method 3 will meet at some point. Okay, so both are literally equal. By seeing the equation, this looks different, but when you write a graph, if you see, when the n value becomes greater, then the difference between these two equations is going to be very minute actually, mathematically, if you see. So what I'm trying to say is that overall, on the average basis, overall, if you see, I have told you something, that there should be a balance between your time complexity and space complexity. So coming to the balance between your time complexity and space complexity, I will just tell that method 3 is much more better than method 2. method 3 is much more better than method 2. Okay, fine. So here we are able to clearly prove that method 3 is much more efficient, because see, in method 2 we have taken an array, of size 26, but in the third method we have taken only one variable called x to make the process. Instead of taking an entire hash table, I have taken only one variable called x, and inside that one variable called x itself, all the hash table process have been completed. So method 3 is a improvement from method 2, because same counting process only we did, but method 3 is a improvement process from method 2. So I think we started with bit manipulation, we get into this problem, we saw three methods with time complexity as well as space complexity, and now we have made a big comparison, we have made a clear comparison between three methods, and I'm concluding that method 3 is efficient among all the three methods, because the balance between the time complexity and space complexity is very good in terms of method 3 comparing all the method 1 and method 2. So method 3 I'll just prefer first, and the second immediate one is method 2, which is also very close to method 3. But why I showed you bit manipulation here is that bit manipulation is reducing your space complexity very much. It is reducing your space complexity very much. That is what I was trying to emphasize. That is what I'm trying to emphasize. Okay, so whenever you want, see, this kind of scenario using string, I have shown you one kind of scenario. So in these kind of scenarios, bit manipulation can be used to reduce the space complexity actually. Okay, okay, fine. So this is it for this session. In the next session we'll be starting with the recursion. Okay, so keep on watching. Thank you.